You take in class are really like the only thing, unless you go to the internet. These are like the only like resource that you have for matrices, and it's only 2 days of notes, so it's not too terrible. But you might want to write a few things down, or like 1 or 2 examples so that you're feeling confident about stuff. We're going to start with some basic matrix operations today. I think you'll find today to be pretty easygoing. But first we want to define what a matrix is. You might have some ideas in your head because maybe you've watched the Matrix movie. Okay, a matrix is a rectangular array of numbers that are in rows and columns. So it's just numbers in rows and also in columns. It's always rectangular. Order is another word for dimension. And we say that the order is, we often use like m by n. So that x, I'm saying that as a by, like 2 by 2, 3 by 3. Where m is your rows and n is your columns. So I also like to write down for myself that the order of any given matrix is rows by columns. And when I'm first learning about matrices, I kind of just like repeat that to myself a few times, rows by columns, rows by columns, rows by columns, so that I remember which order it goes. And then I'm going to put a visual here with rows and columns. Okay, I'm just going to use lines, not actual number entries. But rows are horizontal, so that would be 2 rows. Columns are vertical, so like maybe I have 3 columns. So rows are horizontal, columns are vertical. And the last like little vocab bit that you'll need to know, and then I'll talk about these on the next slide, is the entry. An entry in a matrix is basically one of the numbers that's in a specific row and column. So like I might have a matrix in front of you and say, okay, look at the entry in row 2, column 3. Well, everybody is looking at the same spot, right? They go down to the second row and the third column, and everybody's looking at the same entry. So we like to name entries by where they're located, in which row and which column. At this point, you might be also thinking about like an Excel spreadsheet. An Excel spreadsheet, like it's got the columns A, B, C, and then the rows 1, 2, 3, 4. So if I say look in cell B1, we're all looking at the same entry in that particular cell. So matrices are really useful and really important. They're all about organization. We can take data and we can put it into an Excel spreadsheet, and then we can perform different operations with that data, and that would be almost like performing some matrix operations. In some cases. Okay, here are some examples of matrices. And I'll leave it up to you, like if you want to write each one down, if you just want to pick a couple and write them down, that's totally up to you. I have 4 matrices up on the screen. Before we get into the whole order piece, I just want to talk about like what we just saw in the last slide. So notice that all of these are kind of rectangular in nature. If I have this bottom right matrix, there's the same number of entries in each row and the same number of entries in each column, making it more rectangular. It's not like there's just like one entry missing off the bottom. Okay. So they have to be nice and even. matrices use these, we call them square brackets. So they have like little corners on them. So when you have those square brackets, this is where like those juniors who are taking the ACT, you're not guaranteed to have a matrix question, but if it shows up on the ACT, like just don't be like, oh my gosh, I've never seen square brackets before. Like it's just a matrix. It's just some organization of numbers. And again, I have rows. Those are going to be horizontal. I have columns. Those are vertical. And then I have like specific entries. So if I were looking at this first matrix and I said row 1, column 2, everybody would be looking at this is 0 entry. So what I'd want you to do now is kind of like have the little chat with your groups and confirm that you agree on the order of the matrix. So remember, order is n by n, rows by columns. See if you can name the order for the 4, and then I'll call on you guys. So do talk to each other.
Times 3. So that's 1. That one's first, that one's second, that one's third, that one's fourth. Because that's 6, 2. No.
The order is just the hand. So the first one would be 1 by 3. Second would be 2 by 2. Oh, I
This
read
counts.
2 by 1.
Wait, 3.
I remember it's so it's kind of rows by column. So it's just 3 by 1.
Yeah.
So 1 by 4 is on the first. Okay, we both have this one. So on the second one it's 2 by 2 because there's 2 rows. It's just so much rows.
Okay, let's come together. How many rows in this top left? And how many columns? 3. So this is a 1 by 3. This has also a special name because it's a single row. It's called a row matrix. If there's a row matrix, there's also a column matrix. Do we have any column matrices up here? Yeah, the one right below it, right? How many rows? 2. How many columns? 1. So anytime one of your dimensions is 1, you have either a row matrix or a column matrix. And you don't necessarily have to know row and column matrix. I just think it's kind of nice to be familiar with those. Okay, what is the order for this one in the top right? 2 by 2. I have 2 rows and 2 columns. What kind of special rectangle is that? Square. So this is also called a square matrix. And another interesting thing about this matrix, interesting but boring at the same time to me, is the fact that all the entries are 0. So not only can it be called a square matrix, but any matrix where the entries are all 0 can also be referred to as a 0 matrix. I find that one pretty boring because then it doesn't mean anything. Okay, and then the last one, order, we're choosing between, I suppose, 3 by 2 and 2 by 3. The correct one is 3 by 2. 3 horizontal rows, 2 columns. Now, one thing to note is right now it just looks like numbers in a matrix, and that's what most of our notes are going to be today. On your homework, when you get to the back side, there's 3 problems, but they provide meaning to your matrix, which is really where we would use the matrix in the real world. So I'll just make up a story about this matrix right here and talk about how we could represent something with a matrix. So suppose each of my rows, 3 rows, are my classes. So this is period 1, period 2, and period 3. then my columns could represent something else. Like let's say maybe males and females. So I have 1 male student in period 1 and 5 female students in period 1, but I have 3 male students and 7 females in period 3. Okay, so then it's like all organized. And it doesn't matter what those groups could represent. But then it applies meaning to each entry. Like when we look at 2, we know that's the number of males in period 2. So just be aware that when you get to that on the homework, then you're assigning some kind of meaning so you can think about those values. Okay, matrix equality. What do you think has to be true in order for 2 matrices to be considered equal? Okay. So I'm going to let you discuss with your pods. What would have to be true for 2 matrices to be equal? Go for it. Okay, what was kind of like instantly the first thing that came to mind? Yeah, if they had the same order or the same dimensions, okay, that maybe they would then be equal matrices, so same order. And I've heard a lot of groups, right, when I just like gave you some time to talk about it, most people said they would be the same. Like we used that word. Because don't we mean that in math when we say things are equal, they're the same thing? Okay. So then my question to you is, are those equal matrices?
Well, my thing would be because they're both 2 by 2s.
Yeah.
Maybe this equals both 2 by 2s.
So those look like the same matrix?
I mean, they're not the same numbers, but
Well, okay, according to our description here, we said it had to have the same order, right? And now I gave you 2 matrices with the same order. Do those look like equal matrices? In size, but in entries? No. In order for things to be equal in math, they have to be exactly the same. So these are not equal matrices. You know, if I talk about this is period 1 and this is period 2, this is the number of A's and this is the number of B's, and then here's period 1 and period 2, and this is number of A's and number of B's, that's 2 entirely different numbers for A's and B's. Okay? So not only do they have to have the same order, they also have to have the same, what do we call those numbers? Entries. You know, in math, things are the same, or things are equal when they're exactly the same. So we need our matrices, like the only way 2 matrices are equal if they're exactly the same. So maybe I'll do a different one. Give myself a little bit more space here. I'll do, I'll make up one and ask you if these are equal matrices. Are those equal matrices? Yeah, because they're the same order, and while the entries look different, the entries still have the same values, right? So yeah, those would be equal matrices. And it does matter like where the entries are. So like if I had 1, 2, 3, 4, they have to be in the same spots in the other matrix. If I like mix those up, 4, 3, 2, 1, that would not be the same matrix. Okay. So it is important that they're exactly the same. Next up, we're going to talk about adding and subtracting matrices. And I've got two square 2 by 2 matrices right here. If you want to put them into your notebook, first matrix, row 1 is 3, -2. Second row is 5, 4. And then you're subtracting. Second matrix, top row is -1, -3. Bottom row is -2, 2. And this is another one I think, I'm just going to let you loose. What do you think you might do to subtract those matrices? You want to talk about it with your pod? Give an idea, see if people agree. Go ahead and do that. See if you get the same answer. What do you think you might do?
Comes out 5, 1, 7, 2. Here's the board.
Okay, anybody got any ideas that can enlighten us with what you think you might do, Chase?
Maybe you subtract each entry from each other
And how will I know which entries to subtract from each other?
by making sure they have the same order for each entry.
So, like, order would be the full dimensions, but it sounds like you're talking about, like, in the same spot.
Yeah.
Okay. So, similar to, like, something you used in geometry, I would call these corresponding entries because it's like I could subtract the first row, first column entry of one matrix with the first row, first column entry of the second matrix, right? So, yeah, we can really just subtract all the way across. So our answer is going to be another 2 by 2. 3 minus -1 is really 3 plus 1 or 4. -2 minus -3 is 1. 5 minus -2 is 7. And 4 minus 2 is 2. Now you want to check your entries because as I was walking around, I saw some people get the first one right. And then we didn't really subtract the other ones, right? So a way to fix that I recommend for a lot of people, because a lot of people forget to distribute the negative, is you can change it if it's minus to a plus, but then that means everything inside this second matrix changes signs. So this will be a positive, a positive, a positive, and a negative. And then I can just add across and I won't forget to subtract. Okay, so really important with addition and subtraction they don't have to be equal matrices, like exactly the same, but they do have to have the same order. Like every entry had something to subtract with. No entry was just like left out of the game, right? Okay, so they have to be the same order. So I got a 2 by 2 minus a 2 by 2, which gets me, of course, just another 2 by 2. Because I'm subtracting those corresponding entries like Chase told us. So if I give you an example like this, you say what? Can't do it. Now you might be tempted to try to add, like I have a first row, first column with a first row, first column. But this is second row, first column, and this is first row, second column. Those are not the same entries. Okay. So if they don't have the same order, not possible. This one is what? 2 by 1, and this is a 1 by 2. So then, like, what would the answer be? I don't know. I can't add them. Now, tomorrow when we do matrix multiplication is less intuitive. Like, it's kind of intuitive to just, like, subtract or add the corresponding entries. Matrix multiplication, less intuitive. You can actually multiply things that have different orders tomorrow. So we'll talk about that when we get there. Okay. 2 more things to look at before we get some time to work on our homework assignment. This one is solve the matrix equation. So kind of notice what's happening in the equation. I have a matrix plus another matrix. So we just went through addition. And then it equals this matrix, which we talked about matrix equality. What would have to be true? It'd have to be exactly the same matrix, right? So when it says solve the matrix equation, notice I've got some x's and y's in there. See if you can find x and y. And I'm going to call in somebody, but I'd like to hear your reasoning. So think about, like, how did you know what x or y was? If you want to talk with your pod, go ahead. Does anybody think they have found x? Isabella. You say x is -4. Yeah. How did you decide that x was -4?
X plus 5 is equal to 1.
Okay, so we're taking first row, second column, plus the first row, second column. That's x plus 5 equals the first row, second column. Equals 1. And then, like, if algebraically, you could subtract. Now, I would guess a lot of you were able to do that in your head without actually writing down the equation, right? But worst comes to worst, you can always write out the equation. Does anybody think they solved for y? Oh, Alex. Saw a lot of hands, one from every pod. That was good. What'd you get? +5. And can you describe to us what you were thinking about for y's? Yeah, so like you have the -2, there's your -2, right? And then you have to add it with 2y, so you just kind of guess and check some numbers. Okay, so you're just like plugging in, is it 2 times 4, or 2 times 3, or 2 times 5, or 2 times 6? But then it has to equal 8. So you know that it has to multiply to make 10 and then subtract by 2 to make 8. So yeah, that would work. Y equals 5. Excellent. Okay, and the last thing that we want to talk about is something called scalar multiplication. So this is not matrix multiplication yet. We're going to do that tomorrow. That's a little more complex. Scalar, you might recall this as like a word from geometry. Sometimes when you were working like with similar figures, so they had the same shape but they were different sizes, there was a scalar that related the two figures. Like this, the scalar was 2, so this figure was 2 times the size of the other. Okay. So you could just take like all the side lengths and multiply them by 2. So a scalar is really just a real number, and that would be our 3 right here. This is our scalar. Notice that it's not a matrix. So it doesn't have the rectangular brackets around it. It's not a single entry. It's just a number that's being multiplied by the matrix. What do you suppose you might do with that scalar? Multiply it by every single entry. Right? You're just basically going to distribute it through the whole matrix. The whole matrix is getting multiplied by 3. So I could get 1.5, 6, 4.5, 9, negative 3, negative 1.5. Because I multiplied it through to every entry, the scalar disappears, and now I have just a single matrix. Okay, so I can make the scalar go away, and I have a single matrix left over. You may have some problems on your homework assignment where maybe there's a scalar and addition. So you would follow the order of operations, like multiply the scalar through first, and then add matrices if they have the same order. You might also see some examples where like maybe you have addition and subtraction, and there's a parenthesis, so you'd follow the order of operations and do what's inside the parentheses first, and then what's outside. Okay. So you're basically just treating a matrix almost as if it was a real number, but it has lots of entries. Okay. All right, your homework assignment tonight, tomorrow, and on Wednesday are a series of worksheets. So what I did was I just had them printed and put in, like, stapled together. So this is your 3 assignments for the week. You only have to do the first worksheet. We've got a little over 10 minutes. Nice chunk of time to get a large portion of matrices done. They don't take very long. Finding numbers 1 through 3, you just have to give the order and then move on. I'll come around in a little bit and see if you have any questions. Most of the questions come on the back side when you have to do the word problems. But they're not so bad, you just have to think. And if you want to check entries with your neighbors, that's a great idea. You know, it's easy to make a small